Hello students, I hope all of you well. So in my last lecture I have explained about the scattering of light, how light scatter, why light scatter, and Newton's law of scattering. So why the color of sky is blue. Okay, so from today's class I am going to start the optical instrument. Okay, in our practical life we use different optical instruments. For example, microscope, simple microscope, compound microscope, telescope, about the telescope. Okay, refracting telescope. So first of all I am going to discuss about the simple microscope. Okay, simple microscope is nothing but a convex lens. Okay, it is a simple one, convex lens. Now first we are going to discuss when the image is formed at D, capital D. Capital D means this is D, okay? This U D. D means least distance of distinct vision. Least distance of distinct vision. For a normal eye, we know that least distance of distinct vision is 25 centimeter. Okay? For human, for normal eye, the least distance of distinct vision is 25 centimeter. Least distance of distinct vision means the distance up to which a eye can see image clearly. Okay, so for human, for normal eye, it is 25 centimeter. Okay, now first case I am going to discuss that when the image is formed at D, that means we place an object, an object such that the image will be formed at the least distance of distinct vision, that is D, capital D. So, okay. Now we are to consider this one convex lens. One convex lens with optical center O, focus F, and center of curvature C. Okay. Now we know in optical center, if we place the object between focus and optical center, then it will give us the highly magnified image, virtual and direct image. So we place one object in between focus and optical center, that is AB. Okay, this object AB will give an image, magnified image, A dash B dash at the least distance of distinct vision from the optical center. Okay, now so here U is the object distance, F is the focal length, then D is the, we take it as a image distance. Okay, suppose this I we can see from here. Okay, now so how it will happen? So one ray we consider is parallel to principal axis. After reflection it will go to the focus, and one ray is passed to the optical center. It will goes directly without deviation. Now if you see that these two rays will not meet in this side, so it will meet at the same side of the object. So A dash B dash will be the virtual and highly magnified image of object AB. Okay. Now come to the magnifying power. Now magnifying power is defined as the ratio of the angle subtended by the image at the eye to the angle subtended by the object seen directly when both lie at the least distance of distinct vision. Okay, now when you see the image from our eye, if you see from image from this eye, then between eye and this image, an angle will be formed. Okay, this is the angle. Suppose beta is the angle between this image and eye. Beta is the angle, and what is the object angle. And similarly, if you see the object directly, then also an angle subtended by eye and that object. Okay, let us consider the angle between eye and the object is alpha, and angle between eye and the image is beta. So according to the definition, magnifying power equals to M equals to beta by alpha according to the definition. What is beta? Angle subtended by the image to the eye, and what is alpha? Angle subtended by the object when you see directly the object. Now here m equals to beta by alpha. Now beta and alpha is a very small angle. Okay, beta and alpha is a very small angle. So we can write m equals to tan beta by tan alpha, because for a small angle that angle equals to tan of that angle. Okay, so we can write m equals to tan beta by tan alpha. Now what is tan beta? From diagram, tan beta will be, this is beta, tan beta will be AB by OB, and tan alpha will be dB dash by OB dash. What is dB dash? We can write AB by OB dash, AB by OB dash. So if we put this value in here, so m will be equals to OB dash by OB dash by OB. From put this value, so m will be, what is OB dash? OB dash equals to minus d, and what is OB? So minus f, so d minus cancel, so it will be d by f, okay, d by f. Okay, now let me erase this. Now we know from length equation 1 by u minus 1 by u plus 1 by v equals to 1 by f. Now what is minus 1 by u minus 1 by d? It will be minus 1 by minus f. Okay, so it is minus, okay, it is minus u, so it will be 1 by u minus 1 by d equals to minus 1 by f, plus 1 by f is this one, okay, so 1 by f. So it will be 1 by u minus 1 by d equals to 1 by f. That implies d by u minus 1 equals to d by f. d by u minus 1 equals to d by f. Okay, it will be m minus 1 equals to d by f. So m will be equals to 1 plus d by f, 1 plus d by f. So it is the magnification due to simple microscope when the image is from at the least distance of distinct vision. Okay, now I am going to discuss about the magnification of simple microscope when the image from at the infinity. Okay. So now I am going to discuss about the simple microscope when the image is formed at infinity. Okay. So when the image will form at infinity in convex lens, we know when we place the object in focus. When we place the object in focus of a convex lens, then the image will be formed at the infinity. Okay. So we place one object AB in the focus. So one ray parallel to principal axis, after reflection it will pass to the focus, and another ray is passed to the optical center. So these both rays are parallel, so it will not meet in this side. Okay, but we expect that this will meet at the infinity. Okay. Now here the magnifying power is defined as it is defined as the ratio of angle from by the image situated at infinity at the eye to the angle from by the object to the eye when situated at the least distance of distinct vision. So here in this case, the magnifying power is defined as the angle subtended by the eye with the image. Where the image is from? Image is from at the infinity. Okay, so beta will be the, if the image will be from infinity, so beta will be the angle subtended by the eye to the image we consider. And at the eye, the angle formed by the object to the eye when situated at the least distance of distinction. And what is angle? And what is alpha? Alpha is the angle between the object and the eye when the object is placed at least distance of distinction. Suppose we place the object at least distance of distinction, then what the angle will be made by the eye with the object, that is alpha. So in this case, magnifying power is equals to beta by alpha. Beta is what? Angle by the image, and alpha is what? Angle by the object when it is placed at the least distance of distinction. Okay, understand? So same like the previous case, here also beta and alpha is small, so we can write m equals to we can write 10 beta by 10 alpha, 10 beta by 10 alpha, because beta and alpha is small. So from diagram, what will be 10 beta? 10 beta will be how much? This is 10 beta, AB by OB, AB by OB, and what will be the 10 alpha? From diagram 10 alpha, this alpha, it will be okay, A dash B dash by OB dash. Okay, A dash B dash is AB is same, so it will be AB by OB dash 10 alpha. Okay, now put this value here. So what is 10 beta? 10 beta means AB by OB, and 10 alpha means AB by OB dash, so it will be OB dash by OB, OB dash by OB, OB dash by OB. Okay, AB dash by OB. Now, what is OB? What is OB dash? OB dash is D minus D. What is OB? OB dash is focal length. This minus F, the minus cancel. So from this equation you can write M equals to D by F. M equals to D by F. Okay, so this is the magnification of a simple microscope when the image is formed at the infinity. Okay, so this is all about the simple microscope. We have discussed about the two keys. Now we will discuss about compound microscope. Okay, so now I am going to discuss about the compound microscope. Okay, so in case of compound microscope, we have used two convex lens of different focal length. Okay, now the lens which is placed near to the object is called as a objective or object lens. Okay, so objective lens has a small aperture and a small focal length. Okay, and the lens from which we can see the image, that lens is called eyepiece. So from with the help of eyepiece we can observe the image, and the eyepiece lens has a larger focal length than that of the compared to the objective. Okay, and it has larger aperture. So first we will discuss about the compound microscope when the image is formed at D, that means at the least distance of distinct vision. Okay, now here we consider one compound microscope. This is objective lens, this is eyepiece lens. Okay, and we place this F0 is the focal length of focus of the objective, F is the focus of the eyepiece. So we place one object between focus and center of curvature near the objective. So this object AB will give an image, give a virtual and inverted virtual and indirect image of this virtual and okay sorry, the real and inverted image of this object AB. Okay, this is real and inverted. So AB is the object and ADS BDS is the image of the objective. Okay. Now, so we have to adjust these two lenses such that the object, the image of this object AB is formed between the focal length and optical center of eyepiece. Listen carefully. We have to adjust these two lenses in such a way that the object of this objective lens gives an image which is formed between the focus and optical center of this eyepiece lens. Okay, and the final image is formed at the least distance of distinct vision. And the final image is formed at the least distance of distinct vision. Okay, understand? Now, here it is the object of objective. ADS is the image of the objective lens. Now, again in second case for eyepiece lens, ADS will act as a object act as a object. Okay, and for ADS object, the image will be formed at the image is from is ADS which is highly magnified. So here ADS is the object for eyepiece and ADS will be the image. Okay. So here you know this is the object distance of objective. D is the image distance of this eyepiece. U is the object distance of this eyepiece lens, and V naught is the object image distance of this objective lens. Okay. Now come to the magnifying power. Now here in this case the magnifying power is defined as the angle subtended by the image to the eye to the angle subtended by the object when they are at the least distance of distinct vision. Okay. Here A will be the final image. So beta dash will be the angle between the final image and the eye. Okay. And it is the object to consider. So this will be object and which is from at the least distance of the distinct vision. Okay. So here beta is the angle between the object, image and the eye, and alpha is the angle between the object and the eye. So magnification will be m equals to beta by alpha. M equals to beta by alpha. Now again beta and alpha is small, so we can write 10 beta by 10 alpha. 10 beta by 10 alpha from this diagram. What is 10 beta? A dash by A double dash B double dash by C2 B double dash divided by Q B dash Q B double dash divided by C2 B double dash. Okay, so it will be A double dash B double dash by C2 B dash divided by Q B dash means it is equals to AB because object C2 B double dash. Okay, it is clear. Now from this we can write A double dash B double dash by AB into C2 B double dash by C2 okay, C2 B double dash, no, C2 B double dash by okay, C2. So this is cancelled. This clear to M equals to A double dash by AB. So here you can write it will be A double dash by AB. Okay, so if we multiply A double dash B double dash by AB into A dash B dash by A dash B dash, let's write. So A double dash B double dash by AB into A dash A dash B dash by AB A dash B dash by AB. There again right. So now see the diagram. M equals to Now what is A double this? A double this by A this B this. A double this B double this by A this B this. This is the magnification of eyepiece. Okay. Size of the image by size of the object. Magnification of eyepiece. And this is the A double this by AB. A double this B A this B this by AB. This is the magnification of the objective. So ME equals to M naught. M equals to ME into M naught. Okay. So again ME equals to M, you can write V by UE, V by UE and M naught you can write V naught by U naught by the formula. Okay, by the formula. So if we apply the length equation for eyepiece length equation, now we have to apply the length equation for eyepiece length. So I have written here length equation of eyepiece length will be minus 1 by UE plus 1 by VE equals to 1 by FE equals to 1 by FE. Okay. Okay. Now divide it. UE by FE. Okay. VE by UE. Okay. Now multiply both sides by VE, so it will be minus VE by UE plus 1 equals to VE by FE. VE by FE. So what is VE by UE? It is ME. ME equals to minus ME plus 1 equals to VE by FE. So from this equation, ME equals to, we can write 1 minus VE by FE. 1 minus VE by FE from this equation. Okay. ME equals to 1 minus VE by FE. Now using sign convention, for this ME will be 1 minus what is V? V is D. So it will be minus D, minus plus D by FE. FE is plus. This side FE is plus. So ME equals to 1 plus VE by FE. And M naught will be equals to minus this plus V naught by F naught. So what will be the M? From this, if we put the value, what will be the M? M equals to, we can write M naught into 1 plus D by FE. M naught into 1 plus D by FE, or you can write M equals to V naught by U naught 1 plus D by FE. 1 plus D by FE. This is the equation for magnification of compound microscope when the magnifying power of compound microscope when the image is formed at the least distance of distinct vision. Now, okay. Now, if we consider that this AB is lies very near to point F naught. If we consider this AB lies very near to, if we put this object nearby focal length, okay, so what will be the object distance? Okay, I have removed this. If suppose U naught equals to F naught, U naught equals to F naught, okay, so V naught will be, if U naught equals to F naught, then what will be the V naught? If this is come near to, so it will be also very near to this eyepiece. Okay, it will be very near to the eyepiece. Suppose consider this length of this tube of the microscope is L. So if we take this object very near to focal length of the object lens, the image will be from very near to eyepiece lens. So this distance is almost equal to this much. So if v naught equals to f naught, we can write v naught equals to L. L is what? L is the length of the pie of the cylindrical pie of the microscope. Okay, now put this value here. So m equals to, we can write m equals to v naught means L by f naught 1 plus d by fe 1 plus d by fe. Okay. So this is the magnifying power. So we have got m equals to L by f naught into 1 plus d by fe. So this is the magnifying power of a compound microscope when the image form at the D. Okay. So this is about the today's class. Simple microscope. I discussed simple microscope and compound microscope when the image form at the D. So your class work is you have to find the magnifying power when the image form at the infinity. Okay, it's very simple. You can use your book. If you not understand, you have to do it in your classwork time. Okay, so just go through this today's lecture. So in my next lecture, I will discuss about the different telescopes. Okay, so thank you.